Hey there, this is Mathcamp321, and this is going to be part one of a several-part series on logarithms. In this first part, we're going to talk about conversion. So, what is a logarithm anyway? I remember when I was in high school and my teacher said that we were about to start a unit on studying logarithms. I was really intimidated. The word logarithm in itself is kind of scary. But what I learned is that a logarithm is just another way to express an exponent. Exponents and logs are connected in the following way. Well, in our class we just studied exponential form, which is the form underneath the blue text. A to the power of c equals b. Logarithmic form just takes these elements a, b, and c and places them in slightly different positions. If we look at the equation under the green text, we would read it in the following way. Log of b base a is equal to c. So there is this connection between logarithmic form and exponential form. What we'll explore on the next slide is how to convert back and forth between these two forms. So on this slide, I'm going to show you how to convert from logarithmic form to exponential form. In my school, we call this a swing. What you're going to do is you're going to look at this little a in the log expression, this little base a, and that's where you're going to start, and you're going to raise that to the power of c, and that's going to equal b. So you formulate your exponential form by starting at this little a, and then you swing up to the right and then follow through to the b. So we end up getting a to the power of c is equal to b. And these two forms are equivalent. Let's practice. Convert from log form to exponential form. In other words, do a swing. So we start with number 1, which says log of 25 base 5 is equal to 2. If I do a swing, I will end up getting exponential form. So to do this, we start with this little base of 5. I swing up to the right where the 2 is, and then I follow through and end up at 25. This can be perceived as 5 to the power of 2 is equal to 25. Moving to example 2, we read log of 1/8 base 2 is equal to -3. To write this in exponential form, we'll start at that little base of 2, we'll swing up to the right towards the -3, and then we land at 1/8. So having done the swing, we get 2 to the -3rd is equal to 1/8. Moving to example 3, we have log of 64 base 16 is equal to 3/2. Doing a swing now for the third time, we start with this little base of 16, we swing up to the right to 3/2, and we follow through and land at the 64. And then we can write 16 to the 3/2 power is equal to 64. Now, to convince yourself that this is right, if you're not super comfortable with fractional exponents, we can remember that a fractional exponent is the same as a radical. So if we wanted to write 16 to the 3/2 as a radical, it would be the square root of 16 then cubed equals 64. Let's see if that works. The square root of 16 then cubed equals 64. Well, the square root of 16 is 4, and 4 cubed is 64. So that just confirms that what I was given is actually a valid statement. And it's also a nice little review of fractional exponents. Let's take a look at number 4, our last example of swinging. Immediately, something strikes me as being a little bit different, and that is there's no little base given to us. Well, it just so happens that in this case, when there's no base given, there is an assumed base of 10. This is known as a common log. A common log is a log of base 10. So if you want to, you can actually write the number 10 in as your little base. Once that base is clearly identified, we can do a swing and write the problem as an exponential equation. Having done the swing, we get the result 10 to the power of 0 is equal to 1. So on this slide, we learned how to convert from logarithmic form to exponential form. And at my school, we call that a swing. So in this last slide, we're going to be going in absolutely the opposite direction of what we did on the previous slide. We're going to be going from exponential form into logarithmic form. And for some reason, students find this to be a little bit more tricky than going forward. So I'd like you to start by looking at exponential form in blue and take note of the fact that we've got a base of a. Well, the base is a over here, and if we look at logarithmic form, the base is still a. So just kind of remember that, tuck that away, that the base, whatever the number happens to be, will be the same base whether in exponential form or in logarithmic form. Also take note of the positioning of b and c. They seem to switch from one form to the other. In logarithmic form, the b is on the left, but in exponential form, the b is on the right. Furthermore, in logarithmic form, the c is on the right, and in exponential form, it's on the left. So there's a little bit of a switch going on there too. But I think the best way to start is just to focus on what that base is. Let's take a look at a couple of examples. The directions are to convert from exponential form to log form, or more technically, unschwing. Number 5 says 9 to the 1/2 power is equal to 3. This is like the square root of 9 is equal to 3. Let's really hone in on the fact that that base is 9. The base as an exponent will be the same number base in our logarithmic form. So we end up getting log 3 base 9 is equal to 1/2. Now if you're not completely confident with your answer, you could always do a quick swing to check. That would be starting at base 9, swinging up to the right, and landing on 3. This would yield 9 to the 1/2 power equals 3. And that's exactly what we started with. So we did it right. Let's try example 6. In example 6, we see 10 to the negative 1 is equal to 1/10. Our base is 10. So that's going to be the base of my log. So we get log of 1/10 base 10 is equal to negative 1. Again, if you're not completely confident with that, do a quick swing to check. That would be starting with the little base of 10, swinging up to the right, and landing on the 1/10, yielding us 10 to the negative 1 is equal to 1/10. So there we go, we're 2 for 2. Let's go to the third example. The third example says 2/7 squared is equal to 4/49. Our base is 2/7, so the base as an exponent will be the same base when in logarithmic form. So we end up getting log of 4/49 base 2/7 is equal to 2. If you're not sure, do a quick swing. 2/7 squared equals 4/49. Looks like we're doing good. For our final example, we have 8 to the negative 5/3 is equal to 1/32. Keep in mind that that base is 8. So we end up getting log of 1/32 base 8 is equal to negative 5/3. When we swing to check, we get 8 to the negative 5/3 equals 1/32. And that's exactly what we started with. So in these 4 examples, we went in the reverse direction as on the previous slide. We went from exponential to logarithmic form by doing what's called an unschwing. One very quick comment about number 6 is that we wrote our answer with a base of 10. And we discussed in the prior slide that if the base is 10, you don't have to write it at all. That's just the common log. So this is the same as log of 1/10 equals negative 1. So basically the rule is if the base is 10, you don't have to write it. It's known as the common log. So on these slides we've learned how to convert from exponential form to logarithmic form and from logarithmic form to exponential form.